Part 2 of Episode 2, Lean Management. Welcome back for Part 2 of our Lean Management episode. As mentioned before, my name is Tom and I am the host and creator of the Lean English podcast. If you are listening to the podcast for the first time, we have been discussing the principles and philosophy of lean management, so check out Part 1 if that interests you. Today, we will cover the tools and techniques we use to make lean work. Throughout this second part, I will be referring to graphics that can be found in the PowerPoint presentation for this episode. You can download it at leanenglishconsulting.com or visit the Lean English podcast channel on YouTube. Okay, let's jump right in. This slide shows W. Edward Deming's Plan, Do, Study, Act cycle that he promoted broadly to Japanese engineers. PDSA is used to test and implement changes within an organization, primarily for process improvement and continuous learning. It works well with Principles 12, 13, and 14 that we discussed in Part 1. I recommend starting with small-scale tests until you understand the method fully. Here is a step-by-step approach to using the tool, according to Deming. Step 1. Creating the plan is the most important part of the cycle. Do not rush it to move on to Step 2. Document all the current ideas for an improvement, innovation, or new method, and then brainstorm for new ideas. Then decide which to test during an experiment. Step 1 is important for a number of reasons. You need a good list of ideas to choose from for your test. If you don't capture the right ideas, you will never test the variable that is most important for your improvement. It also helps to clarify the purpose of the test and align it with your company's goals. And when you start asking for advice from subject matter experts during this step, you will find natural allies who want to improve the process for their own benefit. Step 2. Once the experiment is planned, carry out the test, comparison, or experiment, preferably on a small scale. Make sure you capture as much data as possible about all the variables, as you never know what piece of information will lead to the breakthrough. For example, different tools, materials, measurement systems, and operators may influence your outcomes and lead to different results. Step 3. Study the results. Do they correspond with your expectations? Evaluate what happened during the test. Measure the influence of the inputs on the outputs. Document what you learned. Step 4. Use what you learned to act. Adopt a change, abandon a previous idea, or run through the cycle again, possibly under different environmental conditions. This is the tool Lean uses to validate process changes. We will see in our next episode that Six Sigma uses a much more rigorous method of experimentation if your problem requires it. No matter what type of change is needed or type of project you choose, creating a detailed process map is essential. The purpose is to document the process and understand it so well that you can draw a map of where the value is added, where waste exists, the inventory levels, and other necessary information. Value stream maps follow the process as it moves through departments, operators, and steps. Again, the focus is on the entire system, not just a single functional area. On the map I will show you in a minute, each step's processing time is calculated and shown if it is value added or non-value added. Symbols and lines are drawn to indicate the flow of materials or information, and inputs and outputs are identified before and after steps. Drawing the map is a product of intense study by subject matter experts or a specially formed Tiger team. Now, there are many types of maps, each with their own benefits and drawbacks. You need to choose the process, the level, and the data that you want to show for that particular audience. The process will be the workstations that you are interested in. At what process step does your map begin and where does it end? The level will determine how much detail you include. Are you measuring every movement that the worker uses to perform the task? Or are you more concerned with their productivity in the morning versus the afternoon? The data can capture value added versus non-value added time, track the time waiting for resupply, show the amount of scrap created by a process, literally anything that interests you. And if you are creating a map for an executive, it should look different from a map you create for an engineer or worker. So don't feel like you must conform to any map rules. There are no map police who are going to come around and ask to see them. They are only for you, so just make them relevant, easy to understand, and informative. Generally speaking, a non-value added activity is anything the company does that the customer is not willing to pay for. But to be more specific, Lean has identified 8 forms of waste that we should eliminate everywhere we find them. They are transportation, inventory, motion, waiting, overprocessing, overproduction, defects, and underutilization of personnel. Transportation, moving anything without benefiting the customer. In the factory, workstations are purposefully placed close together to reduce the distance the product needs to travel before it is completed. This does not include delivery of a product, which will almost always incur a cost for the customer. Inventory, the high cost of poor planning. If you purchase a lot of spare parts because it is cheaper to buy in bulk, or build parts because you anticipate selling a lot of units, you waste money on keeping it safe until it is ready to be added to the finished product. And it may become obsolete before that time, particularly if you are producing some type of technology. This is a risk you don't need to take. Motion. All unnecessary motion must be eliminated. As tasks are repeated perhaps hundreds of times a day, it is essential to limit the motion involved in each task. A reduction of just a few seconds can reap large benefits over time. It is important to design workstations so the worker has everything they need within an arm's length. Waiting. These can be seen as gaps in the production flow. It is a waste any time a worker is prepared to work on the product, but it has not been delivered to them. They could be adding value and keeping the production flowing, but they are waiting instead. Overprocessing. This is when we find ourselves working on the product after the definition of done has been met. This is also when the design team adds features that the customer does not care about. Lean engineers create the definition of done for every task, and once the definition has been met, the product needs to be moved to the next station. Another term we use for this is gold plating. Overproducing. Some companies produce more than their customers demand because they believe it is cheaper that way. The production team has the incentive to produce as much as they can, so they keep working even though the sales team cannot sell all those units. They are choosing batch production, which is the opposite of generating flow. This leads to inefficiencies throughout the company. Defects. Each defect is an opportunity to lose a customer. Each nonconformity must be fixed. If the defect is detected and fixed in-house, then the production flow stops and additional personnel and other resources are required to fix it. If the defect reaches the customer, then the company will have to pay the costs of a replacement and any damages in the event of an accident. Their reputation will also suffer, as the customer will undoubtedly tell 10 people they know about the poor quality. So we see that the closer the defect gets to the final customer, the more expensive it is to repair the defect. Underutilization of personnel. This is a form of wasting your company's talent. Employees are assets that companies must utilize properly. However, if the workers are given jobs that do not take advantage of their many talents or disregard their suggestions, then the company will not reap all the benefits they could. So now that we know about process maps and the different types of waste, let's look at an example of a value stream map from one of my first process improvement projects and see how it shows us where value is added and where waste exists. This is the process of preparing a used car for sale at one of the companies I once worked for. The company purchased used cars from individuals, repaired them, and then resold them. I worked in the maintenance department where the cars would go through 5 repair steps. It starts with an initial inspection that identifies all the problems that need to be repaired. Then the mechanics would repair the engine and main components, and then the body shop would work on the exterior, repairing dents and repainting if necessary. After that, workers would repair the interior upholstery, seats, and carpet, and then it would get detailed and displayed for sale. A detail is when the car is thoroughly cleaned inside and out. The whole process starts with the maintenance control office, who communicate with the purchasing department and the sales department. The purchasing department tells them about the cars they recently purchased that need to be repaired. Then the maintenance control managers schedule the repairs depending on the demand from the sales department. Customer demand sets the maintenance department's takt time, which we will discuss later. We can follow the car as it passes through the repair process by following the arrows from left to right. On the left side of the map, the green box tells us that 35 cars enter the process each business day. The triangle with the letter I in it indicates the inventory for the step. The first step is the initial inspection process, and the data block below gives us the details. The value added time is 45 minutes, as 35 cars are inspected by the staff of 5 technicians. The repair report is written, and the car waits 24 hours for the repair to begin. The mechanics repair any mechanical problems and change all the fluids. Again, we see that the 20 technicians have the capacity to complete the tasks for all the cars. We see that these steps are part of a pull system, which means that the next step, in this case the mechanical repair and lube, is ready to work on them, and there is no backlog or inventory. Each car takes about 4 hours to complete this step and then waits for the next day to move to exterior work. Here, the 35 cars are met by only 4 paint technicians who do not have the capacity to keep up with demand. They are only able to process about 25 cars a day, with 10 entering the backlog as inventory. Production flow is interrupted as the 4 paint technicians are not prepared to work on all the repaired cars. And we see in the upholstery and carpet repair step that backlog continues to build as the 4 upholstery technicians do not have capacity to complete 25 cars in a day. So an additional 5 cars are added to the backlog inventory, and only 20 cars move to the final step the next day. Between steps 4 and 5, there is no backlog, as the 6 detailers can handle 20 cars a day, which then leave the repair process and are delivered to the sales department. In the bottom right corner, we see the calculated non-value added time is 5,760 minutes. This is time when the car is not being repaired but is waiting for the next step. The value added time is only 510 minutes. So even though the car is available to be worked on for nearly 6,000 minutes, less than 60% of the cars that enter the maintenance repair process exit on the 5-day schedule. When we review this map, it is easy to see where the backlog accumulates by the red inventory triangle between the steps. And when we review the data block, we see that the number of paint technicians is only 20% of the mechanics. During our process improvement event, further examination showed that there was a significant bottleneck in the painting department. What is not shown on our value stream map is our outsourcing operation. What do you think happened to all the vehicles we could not repair in-house? We had to pay someone else to repair them. To increase our production, the company would outsource the vehicles in the backlog to subcontractors, painting and upholstery companies who would do the work for which we did not have capacity. This caused the company to use a push system instead of a pull system, since our own workers did not have the time to complete the repairs. Using subcontractors reduced the inventory backlog and increased our productivity, but greatly increased overall costs as well. This is generally seen as a poor long-term strategy for companies. Let me know in the comments if you would like to know how we fix the problem without hiring new staff or using subcontractors. Now let's talk about inventory management. If we remember back to our history lesson from episode 1, we discussed how Lean developed. Even though Toyota adopted Ford's assembly line approach to production, they did not have the space or capital to have warehouses full of parts waiting for production. And during a visit in the 1950s, Toyota executives noticed that Ford's production still depended on massive amounts of inventory. Ford did not have the same limitations in capital and space as Toyota did, and were able to warehouse their parts without too much worry. This is because in the years following World War II, there was not a lot of competition from imports. Most of Europe and Japan had been bombed so heavily that it would take decades before they were a threat to American automakers. So while Ford could have been streamlining their supply chain, they were instead working as if improvements did not need to be made. For the Toyota executives, these visits did little to help them with their supply chain and warehousing problems, but they found their inspiration for just-in-time in an unfamiliar place. It was their visits to American supermarkets that provided the idea to change their supply chain. Supermarkets used pull systems to replace only the goods that were purchased. If their customers purchased 100 cans of corn a week, they would order 100 cans of corn a week. If they purchased 120 apples, they would order only 120 apples. If they purchased more than that, the apples would not sell and eventually spoil. Kiichiro Toyota noticed the benefit it would have on his small production facility, and their weakness could soon be turned into a strength. With no space in the small factory to store parts and supplies, this system allows production to run smoothly with minimal effort. Toyota coordinated with their suppliers to deliver only one day's required supply of parts. In this fashion, they did not have to build warehouses and pay workers to manage them. They merely opened their doors, unloaded the parts for the day that their suppliers delivered, and started assembly. This reduced transportation and inventory costs and launched just in time, the right part in the right amount at the right time. It also works well with Haijunka, or workload leveling. If one process step takes longer than the previous steps, then they are not prepared to pull the product when they should. Production loses flow, and everyone notices. All these principles work together to create a system that quickly alerts managers when there is a disruption in production flow. In a push system, it is normal for the supplies to build up between process steps, which hides defects and waste in the system. This graphic shows us how to use the Kanban replenishment system with a big bin, small bin setup. In the beginning of the production day, both bins are filled with supplies. In the bottom of the big bin is a Kanban card. The worker takes the supplies from the big bin until it is empty. Then they place the card on a signpost to alert the inventory worker that they need a refill. In the meantime, they use the parts from the small bin. If we know that it takes 30 minutes to receive the parts, and we use a part every 3 minutes, then we stock 10 parts in the small bin. After a 30-minute wait, the delivery arrives, the supply worker fills both bins, and we start all over again. So by now you are asking yourself, how am I supposed to synchronize all these activities with the production flow, customer orders, and supply chain? Tom, is it even possible? How do I do all this? Well, in order to carefully predict production times, synchronize delivery, and optimize flow, we must understand a few statistics. We will cover more complex ideas like cell theory, single-minute exchange of dies, and the critical path in future episodes. But for now, let's start with some basics. Lead time is the time it takes a company to fulfill an order. There are internal and external lead times that need to be measured. If a person orders something, they normally get an estimate on the delivery time. The company calculates the lead time to let the customer know when they can expect it. With this information, the company calculates their takt time. The formula is takt time equals time available divided by units required. If the company gives a delivery time of 8 hours for 40 parts, then they will need to make 5 parts per hour. This gives them a takt time of 12 minutes. They need to produce one part every 12 minutes. Cycle time is the time required to complete one cycle of an operation. On an assembly line, units are produced in a flow of production. After the first unit is produced, the time for the second unit to be completed is your cycle time. In our previous example, the company needs a cycle time of 12 minutes or less to meet their delivery time. Reducing variation in cycle time makes the system more predictable. So now we see that takt time is driven by customer demand, or the voice of the customer, and cycle time is driven by the voice of the process. We will discuss these further in future episodes. Now that we have discussed inventory management and production statistics, let's talk about how Lean creates consistently high quality products with standard work. Using standard work is important even if you are not implementing Lean in your business, because it is very difficult to identify the root cause of a problem if the quality of your product changes all the time. There can be no improvement where there are no standards. There must be a precise standard of measurement for every worker, every machine, and every process. So even before the PDSA improvement cycle is employed, it is essential that the current standards and processes be stabilized. Such a process of stabilization is often called the standardized do, check, act cycle. Only when the SDCA cycle is at work can we upgrade the current standards through the PDSA cycle. In the first stage, we create a standard for performing a task, create the process, document a standard operating procedure, and perform training. In the second stage, perform the process. Make sure that the workers receive support and feedback about their performance as they acquire the muscle memory needed to perform the task correctly. During the check stage, monitor and evaluate the process's performance. Is it creating consistent quality and predictable outcomes? Can we identify variation over time between workers or with different machines? After you have verified the data, act in the fourth stage. Make a decision if further training, documentation, or measurements need to be added to improve the process's performance. The next 3 slides cover tools that are used to make it easier for workers to complete their repetitive tasks on time with a high degree of quality. The first is foolproofing, or in Japanese, poka-yoke. Poka-yoke shows up throughout lean manufacturing because it focuses our attention on the needs of the customer or worker. In design, it requires the designer to ask, what is the simplest way I can design this product so it can be used only in the manner intended? For example, pumping nozzles at the filling station will normally only fit the type of car that uses that type of gasoline, making it difficult to put diesel fuel in an unleaded vehicle. In the factory, it provides the worker on the assembly line with only one way to complete a task. Color coding, graphics, and different size connections take the guesswork out of repetitive tasks. The less the worker has to think, the faster they can move. In much the same way that workers are helped with foolproofing, Lean suggests that management can be supported by using visual cues. This idea is called visual management. Here is a solution for the production manager who needs to understand immediately the progress of each line. Many companies adopt Andon or light boards. In lean manufacturing environments, an Andon board alerts the manager that there is a defect on the production line or someone is falling behind schedule and needs help. Remember that all production activities are synchronized, so if one process falls behind, the whole factory falls behind. So managers must be proactive and stay on top of their team's performance. These boards also aid in quality management. Leadership empowers the workers to stop the production line by pushing a button or pulling a cord. As soon as this happens, a light on the Andon board comes on, and the supervisor rushes to the site to perform a root cause analysis. Lean companies understand that the cost of stopping production is less than the cost of losing a customer due to a defect. Now it is time to discuss the 5S methodology. 5S refers to a house cleaning project that follows 5 steps, each step an action that begins with an S in Japanese and in English. I'm done speaking Japanese today, so I will just give you the English equivalent. The first step is sort. The purpose of sorting is to distinguish between necessary and unnecessary items. If your workspace is cluttered with items that you don't normally use, put a red tag on it and take it to the red tag area, a designated spot in the workspace where everyone brings their useless items. There, the team decides if the item should be kept, discarded, or relocated elsewhere. This is also a good opportunity to see if you really need an item. If you take it to the red tag area and find yourself returning to retrieve it in a few days, you might as well keep it. The second step is straightening. During this step, you organize your workspace in a way that helps your productivity. As a part of visual management, 5S helps you easily identify if something is out of place. In repair shops that must account for every tool, each tool has a designated cutout in the toolbox, allowing a quick review to show if any tools are missing. The third step is sweep. This just means cleaning the area. The goal in this step is to foster a sense of community, responsibility, and pride in the workspace. Everyone is responsible for keeping the workspace clean. Everyone should feel good about working there and be insulted if someone trashes the area. And in some companies, it also helps to have a workspace free from clutter so that you can prevent safety hazards. The fourth step is to standardize the cleaning. For example, the red tags that are used should be duplicated and available so anyone can easily find them, fill them out, and discard an unwanted item. The workspace should identify with clear visual cues the places it is safe to walk and the places where personal protective equipment is necessary. The cleaning schedule should be posted to remind everyone of their duties. The cleaning tools should be kept in the same place and maintained. Standard operating procedures should be shared and followed to ensure that the right chemicals are used and machines are cleaned properly. The final step is sustain. Lean is as much a culture shift as it is a process improvement methodology. Small improvements only matter if the benefits are sustained over time. The cleaning schedule must be kept with 100% engagement of the staff so the mindset of everyone is the same. The message is, we do not work in a dirty, disorganized workspace. We refuse to waste time searching for items. We will organize and clean our space because we deserve a nice place to work. A quick note, if you are thinking about implementing Lean in your organization but don't know where to start, try a 5S project. Sustain it for a few weeks or months and see how the culture begins to change. Then move on to more difficult tasks. Well, that brings this episode to an end. Thank God. You made it all the way through another episode. Congratulations. That might be some kind of record or something. You deserve a badge. And guess what? We have more episodes coming up. So check back next week for the overview of Six Sigma and then Agile the week after. Those are going to be so much fun. Again, here is our contact information. You can find us at leanenglishconsulting.com and send us an email at info@leanenglishconsulting.com. I would love to hear from you. As I mentioned earlier, there is a PowerPoint presentation and transcript of this episode on our site and on the Lean English Podcast YouTube channel. So check those out as well. And if you enjoyed this video, hit the like button and subscribe if you feel like doing me a favor. I mean, I saw that some people watched the last video but didn't hit like. What is going on with them? Come on. Well, that's it for today. Until next time, be good, and I'll talk to you later.